separately. All right. Yeah, let's start on this side. All right, so this one, let's see what we got going on. So my hydrofluoric acid, which is a weak acid, that's my titrant. So if I do 50 times 0.10, that tells me that I have 5 millimoles of that, and that's never going to change. My sodium hydroxide is 0.1 molar. So that's the one that's going to be changing. Okay. So before the titration, all I have is that weak acid. So I'm just looking at this reaction. That's all that I'm looking at. And this started as 0.1 molar. We didn't have any of this, and then we went to 0.1 minus X, X, X. I'm not going to do the rice table every time, but in case you've kind of forgotten how it is. So at this point, I can get my Ka is equal to my H plus times my F minus divided by my HF. Kind of running out of room there. So I don't need to write Ka again. I need to write the actual number. 7.2 times 10 to the negative fourth is equal to X squared. And then 0.1 minus X. And once again, we're going to not worry about X. So when I do all my work, I end up getting X is equal to 0.0085, which is my H plus concentration. I'm going to take the negative log of 0.0085, and I'm going to get a pH equal to 2.07, which makes sense because all we got in there right there is a weak acid. I'm not going to do it on your test, and then maybe we'll talk about it more whenever. But most examples I have and use, they don't do that. And my friend Miss Parker, that's been teaching it longer than me, she said she's never seen them actually put one where you have to worry about that, the quadratic, because it just ends up being so time consuming. I mean, like these problems are time consuming anyway. So you would see this kind of problem on the FRQ. You wouldn't see this problem on, you may get concepts about buffers, but you wouldn't see this problem on a multiple choice. Okay. All right. So before the half equivalence point. So right now, if I do, just gonna get some of this out of the way. I tend to run things together. So if I do 15 times 0.1 molar, that tells me that I have 1.5 millimoles. At this time, I have 1.5 millimoles of my base, of my hydroxide. Okay, so if we just, in between, when you go from starting adding something and like before you get to the half point or the equivalence point, you can kind of just think of it as a basic neutralization reaction. Okay. So my 0.5 that's my acid. That's what I had to start off with. I didn't have any of this. Then my hydroxide, my base, I added 1.5 millimoles. This is the one where if I add something, either the acid or the base, I have to subtract it from the existing species. So in other words, I would need to subtract 1.5 from this. So at equilibrium, I have 3.5 millimoles of my acid and 1.5 millimoles of my base. And the reason you have to do that is this is a neutralization reaction. So when I finally started adding some base, some of that H plus, some of that acid got sacrificed. Okay. And so even if I kind of look here and I think, well, I still have a lot more H plus, a lot more acidic than I do basic. So I still should have a low pH. All right, so now we can go back to using our formula where we say H plus is equal to our Ka acid times base. And we were given a Ka. So H plus is going to be equal to 7.2 times 10 to the negative fourth. Now my acid, I have 3.5 millimoles, but I need a concentration here. So that means I need to divide it by my total volume. So I had 50 mils to start off with, and then I added another 15. So that's going to be 65. That's my acid. I'm going to do the same thing for my base. My base, I have 1.5 millimoles. And my total is that same 65 because these two are being mixed together. Okay, so when you put all that in your calculator, I'm going to kind of shortcut it. This is all ready to go in your calculator right here. You're going to get H plus is going to be equal to 0.0017. So I would take the negative log of that and I would get a pH of 2.77, which makes sense because I didn't put a whole bunch in, so it went up a little bit. So anybody have questions on that? Now 0.3 should be the easiest one because that's when we're at the half equivalence point. So that's when you can just say pH is equal to pKa. So I just take the negative log of my pKa, which they gave me. And that would give me my 3.14. Whoops. And that would be equal to my pH. That should be your easiest calculation right there. All right, I will finish these up and I'll post them in Google Classroom. And I'm going to, and I'll see y'all tomorrow.